Hey, everybody, welcome. Welcome to our From Research to Implementation webinar for the month of November. I'm really excited about this one. We've got some new things to kind of talk about here. We just did have the construction of the test track this last summer and just briefly into the fall. The trucks are running out there. And of course, there's always lessons that we learn when we do this kind of thing. So today's topic is the lessons learned from the 9th cycle of the test track construction. I want to remind you, those of you that are here all the time, you know how some of this works. Those of you that aren't always here, I want to remind you, let's please keep our mics muted. Any questions that you have, let's go ahead and kick those to the end. If you'll put them in the chat box, and I'll remind you of the chat box coming up here in a moment. If we'll put them in the chat box, then we'll address those at the very end. So, given that, I want to introduce our folks that we have today. We've got Nathan Moore, who is the Assistant Director of the Test Track. We've got Jason Nelson, who is our Test Track Manager, and we've got Corey Maupin, who is with Verdkin. And so Nathan, he got his bachelor's and his master's degree from Auburn University. He first started working with NCAT as a co-op student, and then he ended up joining NCAT as a full-time engineer in 2017. He's currently working on finishing up his doctorate degree with some friction is his focus there. He is registered professional engineer here in Alabama, and like I mentioned, he is our assistant director over the test track. Jason Nelson is the test track manager. He holds 2 bachelor's degrees and a master's degree in civil engineering here from Auburn University as well. He's been with NCAT for over 20 years. His focus has been really on surface performance, fleet management, road construction, and so forth there. He's the one that makes sure that those trucks stay running and that they have drivers in those seats. So Corey Maupin is with he is the recycling application specialist for Verdkin America. He has 14 years experience working with Verdkin and 5 years in his current position doing this recycling and being the application specialist there. He trains operators all over the country, and he's been out on and supervised at least 50 recycling jobs in different areas across North America. So with that, I want to turn the time over to Nathan, and we'll get going.
Great. Thank you, Travis. Thank you very much. All right. Well, let me take control of this. Here we go. Slides changing. We good? Everything look good on y'all's end?
Yep.
Great. All right. So here's some of the stuff we're going to talk about today. Just sort of, Travis already covered introduction. With it being, this is the 9th time that the test track has been built, but it's the first time that many of us have been a part of this, in new capacity. So we'll talk a little bit about that. And then, this may be a little different than normal webinar. I've got just tons of pictures, and Jason and I have stories and examples of lessons that we learned, innovative techniques that we tried out. But I'm really excited to have Corey on the call. He's going to spend most of his time today talking about soil reclamation, but Corey was instrumental in working in general that were incredibly helpful to us as we built test sections this summer. So the first time I had a chance to invite a guest on, I wanted to make sure to invite him because it wasn't just the soil stuff. It was CCPR, and it was, all kinds of stuff that they helped us with. So we'll talk through some of that today. But yeah, so I did mention, challenges. And Jason and I sort of had this, from different perspectives, maybe 2 sides of the same coin. Like Travis mentioned, I've been a part of NCAT since 2012 as an undergrad student, and I've experienced test track construction as an undergrad student, as a graduate student, as a lab engineer, and now as test track director. And each one brought its own challenges. This one certainly had the most responsibility. So being new into this role was a challenge for sure. But I would like to sort of hear Jason's perspective and let him comment. Jason was the most experienced person out there, so he was sort of dealing with it from another side.
Yeah, so what's interesting about what we do every third summer is that, we step out of the role of researchers and fleet managers, and we become prime contractors. And it's something we get about 3 months, 4 months experience in. And that's why people like Corey and folks from all of the industry are so instrumental in making sure that the track is successful, because they bring their vast experience in and make sure that we're doing this, following those best practices and doing the best as we can. But like Nathan said, so half of our fleet staff was new for this cycle, and we're still in the process of bringing some folks on. But those drivers and those lab staff, they become quality control experts, and they become operators for rollers and some of our labor. And so we always tell folks when they come on, they're signed up for a truck driving job, but every third summer they get a change of pace. Sometimes that's good for some folks, and sometimes I'm ready to get back in the truck. But yeah, so we all kind of jump in, and everybody picks up a shovel and moves dirt around or drives equipment and make sure it gets done.
And I can say from my perspective, and Jason, I've told you this publicly and privately, I very much consider you as the backbone of the 2024 construction cycle. You had experience to stand on, but your calm demeanor and your problem solving skills, which today certainly shined. So new personnel being a challenge that we had to overcome, that was interesting. But we also got a chance to deal with new materials. So Corey's going to talk later about the clay, and we'll talk more about doing soil reclamation and soil stabilization with a clay from Mississippi and some dirty sand base. But we also used other stuff, void reducing asphalt membrane. We brought in calcined bauxite for enhanced friction. We got a chance to deal with lots of different additives. So each one of those brought unique challenges, and which really paved the way for the opportunity to use new equipment. And so that's really what we're going to focus on today. Is we don't have any findings yet, thankfully, right? If we did any findings right now, that would mean a section would have catastrophically failed. But what we do have is a lot of lessons learned and stuff that we had done, tools that we use, techniques that we use to kind of get us where we are today. So the first thing I'll talk about is precision milling. And a huge shout out to our supporters at Aztec. They absolutely came through for us, and they spent, Jason, what was it, about 4 or 5 days out there with us? Yeah. So they came out after the Test Track conference in May, and Jason and myself and Buzz was still sort of involved at that point, helping out. We had a plan for how many different test sections that we were building, depths, cross sections, and so we milled sections anywhere from 1 inch to 30 inches, and I've got some pictures to talk about that. But
Aztec has been great over the years. They've supported every track construction that I've been a part of, and before the ones that I was here. They come in mid-cycle when you have maintenance issues and help us. And this is not like a standard job out in the real world where you set for 2 inches and you just go for the next 10 or 15 miles. Every 200 feet is a little different, and there's times when we have to do fractional milling. So we're going down 6 inches and we're trying to hit an interface, and we're constantly watching it and adjusting on the fly, and then trying to get those materials separated because they may have value. Research value that we have to, stockpile them differently.
Yeah, and it was interesting to hear the feedback from the folks at Aztec, as they said, like in 5 days, they saw what a typical contractor may see in their entire career as you're milling to maybe correct deficiencies. Maybe you're milling full depth all the way down to the soil. Maybe you're milling in a really steep curve. So it was really neat to hear their feedback, and also just to know like they benefit from our partnership as well. So that was pretty neat. But yeah, so the equipment that they use. Oh, I do have one quick comment. It was a lot of fun as we were doing this because we had Aztec's heavy equipment. We had dump trucks on the track, but we also were doing logging on our infield. So we had all kinds of heavy equipment, all kinds of stuff around.
Perfectly timed to be a nightmare.
Yeah. But thankfully, we had some pretty good safety protocol in place, and we made sure that folks weren't going where they weren't supposed to be going. So, I mentioned about how we did take the opportunity to do some corrective work, wanting to make sure that there are some sections on the track that had failed that we were milling up, and there were other things that we took the opportunity. And Aztec they were so helpful, trying to fix different problems, or in some cases it was just, hey, we have an opportunity to to kind of put a new lift on something that's aesthetically pleasing. And so again, I can't say enough about how grateful we are for them.
It's
But
always
the thing I
interesting.
do want to talk about the most, go ahead.
It's always interesting to problem solve on the fly. So, we've just finished the previous section. We've done 200 feet, and we move up to the next section. We're like, okay, this is what we're trying to do there. And, we've got, 5 or 10 minutes to kind of huddle right there on the side of the track and, make sure that the research objectives are being met. And, we want it to look aesthetically pleasing. And so it's great to lean on those operators that can come in and just, you give them a weird situation, and they can play jazz, so to speak, and they can figure it out on the fly.
Yeah, yeah, absolutely. I can't say enough about just their flexibility and professionalism, because it's like Jason said, this was not a typical 2-inch depth, go for 3 miles kind of thing. It was every 200 feet you're just doing something differently. So anyway, what I do want to talk about, the Aztecs, what they call their dual averaging system. And so on some of the older models on these milling machines, they had like an 8-foot window that they're able to average over. But using some of the non-contact skis and the capabilities that Aztec had put on this particular machine, we actually had a 30-foot long window that we were able to average over. So you still had the capability to for the milling head to respond instantaneously to input changes. Like Jason said, sometimes we were trying to split 2 lifts and we wanted to not touch the bottom lift, but just sort of kiss the top of it. And so Jason and I would be back saying, okay, go down to 10th or up a 10th. So it could do that on the fly, but as it encountered any roughness, it was able to average it out and really just give it was such a smooth mill when it was all said and done.
So yeah, if you've been on a milling job, you're probably familiar with one of these, and we're used to chasing the mill and checking every 5-6 feet, just constantly making sure that we're at that exact interface. We're trying to mill and pave, to a 1/10 of an inch precision. And so this equipment, this milling job was absolutely just on point and as precise as anything I've ever seen.
Yeah, and I want to, as far as I'm concerned, we're never going back. I mean, it was so helpful. And honestly, clean, smooth milling made for sections that were really easy to attack. And they made for, it was aesthetically pleasing as well. And it made the paving operations, smooth, because our paving contractor wasn't chasing depth. It was a pretty consistent, it was very consistent surface. But one of the more interesting things that we did deep sections. So here's a picture of Jason. What was this? 30 inches down?
Yeah, this is probably S3 or S4. Yeah.
Yeah. So we had some sections where they were actually part of the original test track in 2000, and so they were 24 inches deep, and then we had to get out the aggregate base as well. And so we were able to go down in 3 different lifts, and so 3 10-inch lifts to get all the way down to original track subgrade. And then we had to cut drains, and that was a challenge, because how do you drain a 30-inch hole? But we were able to do that as well. So the next thing I'd like to talk about is VRAM, void reducing asphalt membrane. Many of you guys are probably familiar with this as a technique to improve longitudinal joint density, but we actually used it for a slightly different purpose. So we were looking at applying this to vertical faces. We have done a lot more work at the test track looking at full depth or thick lift paving. So we did a handful of sections that were 5.5 inches in a single lift. And when you do that, you do want to make sure that you are getting good joint density, because you don't have multiple lifts to protect surface infiltration of water. So we learned some lessons in building sections in the 2021 track, and we thought, well, what if we just sealed them up sealed the joints up with VRAM. So this is a picture of the void reducing asphalt membrane applicator from Simline. So they graciously donated their time to come and help us. We specifically used J-band as the product. So this was I think these folks came down from Minnesota, and we were really happy to have them here. Here's a picture of the bags of the J-band material that was supplied by Associated Asphalt. So again, thank you. Huge thanks to those folks for supporting what we do. And these bags are thrown into the melting pot, and they're melted, and they become what is the product that is going to get applied. Jason, I'll kind of let you talk about what we did to calibrate this stuff.
So just like our distributors with TAC, and we always make sure that we calibrate. That's feeds off of work we did for AlDOT going back more than 15 years. And so we go up into one of the kind of off track hills, and in this case we just spread tar paper down. And you can see the operator there. He's leaned over and he's smoothing it out as it's coming down. And so he's kind of smearing it out, kind of like you would with a crack sealing or overband. If we had to do this again, and this is feedback, from not only watching him, but the operator, is we would build some sort of carriage system or some sort of sled that, because you can see he's hunched over, and when he's walking, 200, 400 feet, it was tough on him. So if it was something that, a practice that's adopted, out in the real world, or we do more often, then that's an improvement we can make. But yeah, just spread some tar paper down. We spread out several, I guess this is about 3 or 4 feet. Run that over to the scale and weigh it, and just make sure it's matching the weight of what we're looking.
Yeah, one thing we were specifically trying to investigate before we got on the track was, is this stuff going to run as we apply it to a vertical face? What's it going to look like? And we know this stuff is sticky, and we know it's a good product, but so that's why what you can see him applying it. That's actually about a 6-inch surface right there between where he's standing and then the surface that those 2x4s are on. It's obviously sloped away, right? It's not a perfect vertical face, but that was the trial mix that we had put down a couple weeks prior, and we said, well, this is as close to a vertical face as we have, so let's see how it works. And so we learned a lot of lessons, and we were able to actually kind of go and apply them in the field. Here's a picture of one of the test sections that we were using. So this is a 5.5-inch asphalt mix coming in on top of this base, but it's coming in a single lift. So what we were doing is we were going to put VRAM to prevent low density on both the inside and the outside joints. Jason was mentioning earlier about the application system. We did kind of bootstrap it together, and it worked well. But if something like this was ever done in a rapid rebuild environment where they were doing thick lift paving and there was a vertical face like this, you would want some type of ski or sled or something like that so that you're not hunched over, just in terms of worker safety. But you can see on the picture. Go ahead.
And it was actually instrumental to make sure these surfaces were very clean prior to applying this. There was just a couple of spots here and there where there was a little bit of dust, and it really affected the adhesion, especially here on this granular base with those unbound fines that can not only just blow up in there, or maybe were there from when it was just constructed initially.
Yeah, and so we got out there, and we with the broom, and then also just some hand broom in some sections to make sure. But again, this is the first time that J-band or VRAM, to my knowledge, had been used in an application like this. So we didn't know how clean is clean enough as it relates to that's J-band bonding, if there was a film of dust or something on there. So we did kind of try to go above and beyond. Here's another picture of the product once it's done, and what you can see is it really didn't run that much. So here's an even better picture on the left. You can see it didn't really run that much at all. But one of the things that we did learn is on any of the full depth sections, this product went down very well. Obviously it's buried, we can't see it. We do have a plan to take some cores and do some image analysis to see did the VRAM migrate horizontally, whereas typical application has it migrating vertically. So we do intend to look at that. We did put VRAM in a section that ended up having 9.5 inches of asphalt, but in multiple layers. And I'm showing that on the right because this was a lesson learned, right? Jason mentioned earlier if we could do this again, or when we do this something like this again, we will apply some of these. VRAM worked really well for single lift, but for multiple lifts, what you're seeing there on the right is when the rollers were compacting those underlying layers, it just kind of scraped them off the side. We have to pinch the joint a lot in what we do to make sure that we're getting good density. And in this case, you're running right up there against the edge, and every once in a while the roller would scrape, and it ends up sort of removing all the VRAM off of the wall. Jason, you got any other comments on VRAM before we talk about other stuff?
Yeah, so I guess the question would be, why didn't you just apply it in multiple applications? But we were limited by how long the vendor could be here. They only had about a day and a half, 2 days that they could spend with us, and so everything had to be applied at one time. So it's not something we could have really worked around in this case. But in the future, maybe that's something we can work on.
That's right. And we did put some VRAM down in some other test sections that were just a single mill and inlay. And in that case, it was a more traditional application. But yeah, we built these sections, one after the other, 4 days in a row with a hurricane and a weekend in between. So yeah, we couldn't ask the distributor to stick around the whole time. So this whole time we were saying, we don't really even know what we're looking for anyway. So let's all learn together. And some folks from AMI came down, and some folks from Associated Asphalt came, and they were really instrumental at helping us because they wanted to learn as well. Like, can you do this? How would we do this in the future if this would ever be helpful if anyone else faced a unique situation like we did? So now I want to shift and go a little bit talking about additive feeding systems that we use. And again, what we're trying to highlight in this webinar, it's not necessarily major test track findings, but these are tools that we use to solve problems. And whether it was from milling or feeding systems or a VRAM application, these are off-the-shelf tools that we use maybe in innovative ways or necessarily innovative ways because we felt we dealt with a unique problem. But many of you guys there listen to this, you're probably familiar with high-tech system. And so you're looking at this and it's not the big blue box that you're used to seeing. Well, high-tech they've actually developed these smaller feeding systems that they've developed with the intent to add dry additives at lower dosage rates into the mix. So I mean, some of these things are coming in at fractions of a percent by weight of mix, but they still need to be precisely controlled and monitored. And the larger feeding system could do it. We did it in 2021. But when I got on the phone with High Tech and said, hey, this is what we're trying to do, they said, look, we've got these new devices that we really think are the future of additive addition at asphalt plants. And so they said, why don't you give these a try? So I took them at their recommendation, and man, it was as close to perfect as you could possibly be. So what I'm showing here is a picture of rubber. So this was using a dry ground tire rubber additive into the plant. We put rubber in 3 different test sections on the test track. So obviously I'm just showing you a picture of one of the products. But it's so nice because you would tell it the feeding rate, and then I went and actually checked back, just manually checked weights versus total tonnage in the plant. And I mean, we were within 95% of where we wanted to be on a long production run, which is just outstanding. We were so happy, and in many cases even better than that. So happy. We also used it to apply or to add in dry plastic products or engineered plastic products. So I'm showing you 2 different ones. One of them is like a graphene enhanced polymer. Other one's more engineered polyethylene product, and they all worked well. So these machines had the ability to meter in different materials, obviously different densities, at lower rates than what you would typically see and it did it with excellence. What was so nice is the user interface is what you are already used to seeing, right? So you've got a control box on the side, and you can hook this up, to the plant if you would like to, inside the control tower. We did it from down on the ground, but you're looking at total tonnage or total weight in the hopper, feed rate, current feed rate. You're inputting plants tons per hour. It's giving you alarms if something goes wrong, and I just want to tip my hat to the folks at High Tech. There was one particular time where we were having an issue, getting off the ground, and the plant's screaming behind me, and me and the plant operator are out there just trying to troubleshoot. And we get on the phone with these guys, and I'm not kidding. In 60 seconds, with the plant screaming and it's all this stuff going on, High Tech folks were able to diagnose, hey, here's your problem. Here's what you need to do. Press this button, do this, and we were up and running. I mean, so I not only was their equipment excellent, their service was excellent as well. So I just like to give credit to where credit is due. They were really helpful. The last thing I want to talk about before we hand it over to Corey from Workman is blending soil and doing soil reclamation. So we actually used Workman KMA plant for a couple CCPR sections on the test track. Well, as we were doing that, myself and Jason and Dr. Namtran, we had this soil that we were trying to blend together, and we were thinking of, we were going to put in like a clay, an expansive clay base that we were going to be investigating soil stabilization techniques, which we'll talk more about in another webinar one day. But they wanted to blend some, and then we were going to put sand on top of that, and they wanted to blend some of that clay in with the sand. And we're like, well, you can't do that. We have two different stockpiles, and unless we go ahead and lay them out, and then we do the reclamation, and then it's multiple lists. And so we thought, like, well, I looked at Corey and I said, can we just use your plant to blend these soils together? And Corey's like, I don't see why not. Let's make sure it's not too wet. Make sure it has good consistency. So we use this plant to blend about 75, about 3-to-1 sand to clay, about 75-25. And like I said, it was already stockpiled. So here in this picture, you can see the front end loader loading clay from one side and sand's coming in from the other. Interestingly, the orangish reddish material is sand, not clay. So I kept making that mistake early on. I was like, we don't want to get this flipped backwards. But so we blended it in a central plant just like this, and then we used plant controls to keep the blend proportions what we wanted. So it was a phenomenal experience. I think it actually worked extremely well. So here's a picture of we had two front end loaders operating, one feeding clay from one side and moving much faster than the one feeding sand from the other, just to kind of keep up with the production rate. But we ended up doing this it was about 130 tons, probably, maybe a little bit more than that. Maybe closer to 150 tons of blended material. So here's a picture of it being discharged out into our truck. Interestingly, the Workman plant has got its own plant setup and its own plant calibrations, but we wanted to double check this. So earlier in the day, we actually have kind of mobile scales that we can pull out and drive a truck over and just confirm. And so we've got this truck here, but obviously there's no scale house, there's nothing like that to figure out how much material we had. So we did an additional calibration of the plant by comparing the tonnage readout from the plant that Corey was saying, like, hey, we've put out 50 tons, we put out 100 tons, to the weight of the truck scales, and we realized, like, okay, yeah, this is actually working well. Those of you who are familiar with the NCAT staff, here was our fearless truck driver, Dr. Namtran. Definitely got his boots and hands dirty as he's out there driving our rented truck around and stockpiling this material. So hats off to Nam. He absolutely came through. At this day, we had folks every nook and cranny on the NCAT test track doing different stuff, and Nam's like, I can drive a truck. You just tell me what you need me to do. So there's a picture of stockpile after mixing, and it actually, when we were done, we stockpiled all this material together, and it sat for about a week before we actually were using it. Once we did start using it, this is, we needed to add cement, so we laid out some. Jason and I, we knew what the cement dosage rate was, and the soil stabilization technique that we were looking at, it actually reduces cement usage by, I think we reduced it by about 60%. So otherwise you'd see a lot more cement bags out there. We didn't have, an applicator, and it was such a smaller rate. Jason and I, we kind of marked off a grid of cement bags, calculated approximate spacing, went out, cut bags. Then we went to Lowe's and got some loot rakes and some safety equipment, dust masks and gloves and stuff like that. And here's a picture of myself and Grant Julian spreading them by hand. So here's a picture of the soil reclaimer. So at this point, we sprayed some. We got a water truck over there on the left, and this is where Corey and his team were unbelievably helpful. Corey, I don't remember how much time I gave you, but I called and I said, "Hey, I know you just left here. Is there a way you could come back and maybe bring a reclaimer with you?" And Workman did an awesome job, absolutely incredible. So Corey, I don't know if you've got any comments as I show some of these pictures. Here's a cool, drone footage. And what's neat about this is you can see the line from where the reclaimer has gone, and then it's got to go over in that outside wheel path, and you can see that's where the cement has been spread, that the reclaimer's going through and blending all that together.
The one thing I was going to tell you is that I said before that we had not blended material like that. I was just thinking about it, and we had a customer up in Canada that did, I think it was like 85% wrap, 10% something else, and then a few percent of shingles. So we blended the two smaller products together, made a stockpile, and then did it.
Well, that's awesome to hear, because, as I was thinking through this process, I was like, this is kind of like CCPR for FDR almost, right? Or CCPR for soil stabilization, and using y'all's plant in order to be able to make sure that we are getting the right blend of materials that we wanted. It was tremendous. Yeah. So I absolutely think that, when the job calls for it, you can use this technique to be able to make sure that you're getting the right material composition. Corey, I was going to, kick this one to you, because we talked about the order of construction operations, and we got it wrong the first time. We actually did this twice. So we reclaimed the sandy base, and then we reclaimed the clay base, and then we reclaimed like the blended on top. But Corey, why don't you talk to us a little bit about what order you need to get this equipment in?
So this was one of the things that I saw. There wasn't many things wrong, but this was one of the things that I said we need to stop and do this differently. And if you look at in front of the grader here, you see basically two wheel ruts where the stabilizer went through. And if you look at it this way, that the stabilizer had a rear door that struck the material off evenly, then the rear tires compacted that material, and we're left with a little bit of a high spot in the middle. When they went through and raked or graded this off evenly, basically you added more material over the tire tracks and took away some from the center. And what you end up doing at the end is bridging the roller across those two wheel ruts and not getting density in the center. Just strictly because the roller is nearly the same width as the tire tracks, and it gets supported by those. So that's a really good picture to show what went wrong, or what we were talking about.
So what we should have done, and correct me if after we did this the first time, you suggested like, hey, it's probably not that big of a deal, but why don't you consider flipping the order? And so then I think what we got out there with the sheep's foot, and then we then we bladed it afterwards.
Correct. The sheep's foot should follow the reclaimer, and it should, basically we call it refusal density, or it's kind of a cheap infield method. If the pads start walking out and you're not seeing the imprints of the base root diameter of the drum, then you're up on the pads and you know you're getting some density. So a couple passes in order to get that, and then move over next pass, if you would, and then same thing, and then come in blade it finally.
So we've got some pictures actually that Corey provided. This so just as the final picture. I didn't put a picture of a sheep's foot in here. We were actually out there with a sheep's foot at night at one point, just because we had to make sure we were trying to hit density because we were coming back the next day. But so here's sort of final smooth drum rolling. But at that, I'm gonna turn it over here to Corey, and I'd like for him to talk about just reclamation best practices. So Corey, I've got control of the slides, so whenever you're ready to move on to the next one, just let me know. But I'm gonna turn it over to you.
Okay. This was basically this was a foam stabilized job. You can see kind of in front of the reclaimer, there's an oil truck there. And what you can't see is the water hose coming off the back tying to a truck. So the truck was providing water for your to get to OMC of the mat. But the point I kind of wanted to make with this one is planning ahead. We've got two different tankers that we're going to have to connect to the reclaimer. They're both going to have to be swapped in and out at different times. The water truck is typically 2 to 3 times what the tanker ahead of it pushing the hot oil is. So thinking ahead, what's going to happen, how often you're going to use things, and what's going to need to be done. The contractor here opted to tow the water truck. That way they could quickly unhook it and sub in a different one. Go ahead to the next slide, Nathan.
Sure.
This one is basically a cement stabilized pad or a cement stabilized road. It's kind of hard to say which one, but the one thing that I wanted to point out is that gray line at the left tire. Basically, it looks like it's not blended. What probably happens is with a thick lift of cement, that cement gets pushed over off the side of the reclaimer side plate, and it looks like it's not blended. Perhaps moving over just a little bit, they could have eliminated this, but same thing, making sure you've got your correct overlaps, making sure that all the material is blended and cut properly before going in and compacting it. And you can see here, they made multiple passes, and then on the left, there's a roller in there without the grader following up, compacting everything. Go ahead to the next slide. This one is basically, you can kind of see there in the center of a picture, there's a soft spot. I see this a lot, that there's no provisions made or no readily made ideas for dealing with something like this. You can see most of the rest of the pad is stable and supporting weight, but there's one spot. So the normal contractor just dumps a little bit more either lime or cement in the hole, goes over it twice, and then compacts it and stabilizes it. If that's not what you're wanting, I know a lot of them are starting to focus on a lot of the end strengths, staying below 200 PSI. And I know that's kind of one of the things that we preach. You have to be aware that this is potentially going to be over that and different. So putting something in the specs or setting something in your mind ahead of time, if we run into this situation, these are the likely situations. What are we going to do to fix them? I just think that would be a good pre-planning thing to do for everyone. Next slide. And finally, cement consistency. Nathan talked about, basically they laid out bags in a grid. Most contractors just dump out of a truck with several different methods. I think the next slide's got several different ones, Nathan.
It does. You may go to it.
Yeah, sure. So the stabilizer essentially picks material up and puts it right back down. It does not side shift material more than about 6 inches, and it does not carry material. So if you've got errors where a truck started off, dumped a lot of material, and then took off, and then you've got a fat spot of cement and a lean spot, you can see the top right picture kind of shows lime, and there's a big gap there where it's missing. The soil stabilizer is not going to fix those. It's going to stabilize what it's got there, and if you can't spread the material right, you're going to end up with inconsistencies in your final product. So the left is slurry. It's a slurry, but there's no metering on this at all. It's basically a truck driver putting it into whatever gear he wants and dumping material out the back, and it's spread, but you really don't know what level you're getting. The second picture from the left, you can see wheel ruts and stuff in there. So those, of course, are going to accumulate more than the high spots.
And what's a practical, I'm imagining having kind of variable, maybe densities or variable stiffnesses across the surface. Is that sort of the practical outcome of not controlling your process?
Yes, you would. I mean, basically, we're trying to build a nice even layer, typically using soil stabilization. So if you have a hard spot and a soft spot, essentially you're going to end up with probably a crack in the middle of the hard spot and a soft spot that does not support weight and ruts and pushes up. Same
Well,
thing for the lime. If you had a plastic soil and you didn't get that one spot treated, then you don't know, you're going to have lime pushing up or clays pushing up through that spot.
well, Corey, that sort of concludes what we've got for everybody today. But one more time, I just wanted to thank Corey. I thanked him about 1 billion times in person, both when he came the first time and when I begged him to come back the second time to do what we were just talking about. But the folks at Working Group were awesome, absolutely awesome. We are blessed at NCAT to have the support of the industry, equipment manufacturers as well. So thank you again, Corey. Thank you to everyone at Working who supported us. Couldn't have done it. We absolutely couldn't have done it without you. So thanks a lot.
Thank you all for the opportunity.
Cool.
Travis, at this point,
go ahead. We've had a couple questions roll in. I just wanted to kind of dole those up amongst you here, and we'll
Sure.
figure some things out. So, I would say either Nathan or Jason, either one of you, can you talk a little bit about what kind of effort you guys put in to clean the milled surface before
I'll take this
forward? Thanks,
so
Jason.
here on the track, we don't have the luxury or the curse, depending on how you look on it, of dealing with traffic, in construction. So we don't get the benefit of any, tires cleaning it. So we have to be fairly aggressive with our brooming. At times, it's multiple passes with the power broom, sometimes with added water to kind of rinse that out. But yeah, it's making sure that we're getting that good bond strength and getting that good interface tacked down. Because there's no point in spending all this time calibrating the tack truck and making sure you're getting the right stuff spread and temperatures are all right. And like Corey said, a truck driver that's not just picking a random gear, everything's running that PTO just like you calibrated, and then you're spraying it down on a dusty surface. So we do want to make sure everything's nice and clean.
Yeah, that's one of those points that I spend a lot of time talking about on our training courses is surface prep and the importance of making sure that we get that all cleaned up. If we're bonding to that underlying dust, we've really wasted ourselves. Our pavements are not designed to be independent layers. They're really designed to be, glued together. And so it's important we do that, especially when we're analyzing the material on top, right? We're putting these very expensive mixes out there, or experimental mixes that we're trying to determine, what kind of performance they may have. We need to make sure that we don't put something confounding out there in its place.
And it doesn't take much dust, and that NTV or that shuttle, or the pavers, they're going to start picking it up. And once it starts picking it up, you're going to have that wheel path completely bare through the rest of the project. So it doesn't take much.
Yeah. Yeah, and I've got some pictures of some pavements that I've found around the country, and when I was part of a DOT where, you know, the delivery trucks picked up the tack and started hauling in the tack on the tires back towards wherever the plant was, but then within just a couple months, especially a thin lift, hops right out of the wheel path and is laying in the shoulders. We didn't get what we wanted out of that. So great. Next question was about the R value, or that bearing on the natural soils out there. I was wondering if either one of you could speak to that.
Yeah, Tom, I don't have that number off the top of my head. That's certainly, I think we'll have another webinar about that exact section. So a lot of the more technical questions that I scrolled through, and Tom, you asked a few questions about uh, you know, stiffness targets and R values, and we have that information. I do have to say I don't have them off the top of my head.
Okay, so I do know one thing from several years of doing this web series and talking about, you know, the different sections out there on the track and the different things we've learned, that the subgrade material out there that is the in situ material is very, very stable. That there's
Yes.
a good foundation underneath what was put out there. Now we have in years past, and even in this cycle as well, dug down through that good material and brought in material from another state that wasn't as
Well,
good.
that's
And that's
Travis.
exactly
That's
what
what we
we're
did
doing.
for. Yeah. So we have A4 soil. We're blessed with really good soil, subgrade soil that we're building on the test track on top of.
Yeah.
But it doesn't make good experimental soil for soil stabilization. So our friends over at Mississippi DOT helped us identify a really good candidate for, a soil that they said, hey, this is what we would consider fairly problematic, where they actually gave us kind of one of their worst case scenario soils and said, try this one, so that again, big shout out to the Mississippi DOT for helping us build this test section.
Sure. So next question kind of came in, and when you were applying the VRAM on the vertical face, is there a thought process on why you guys chose to use the wand with the foot rather than use some sort of a spray application?
Yeah, that's a great question and really good observation. It was more of a product of the constraints that we had. So on one case, we weren't trying to overspray into the current inside lane, the adjacent lane, because we weren't touching that. And so we only needed to apply one side. And instead of, in some cases, these sections were so deep that some of these trucks, they didn't want to get down there. They were afraid they'd be able to come back up. Or we would already have like strain gauges and pressure plates, like instrumentation inside on top of the base, and we couldn't drive a distributor over it. So we were kind of pigeonholed. We didn't want to spray from up high, in some cases 9 inches high, and overspray down, because you wouldn't be able to get onto that vertical surface. But we couldn't allow the trucks to be on the actual surface section spraying sideways. On a typical job where you're not installing strain gauges and pressure plates and other instrumentation, that would not be as big of a deal. So you would be able to apply with some kind of spray applicator, as long as you're making sure you're not overspraying into the adjacent lane too far.
But really, the project constraints were kind of it. I've seen the trailers that pull behind a truck apply VRAM material as well. So I know it could be done that way. That may be another modification we could do on something that's unique like this, or out on a real project. So Nathan, was there a reason why you chose to go with the VRAM material versus some of like the joint adhesives that have been out there for probably, a bit longer than the VRAM type material?
I mean, the honest reason, we were discussing this internally, thinking about how we could improve the density on those joints to prevent water infiltration. And VRAM, and specifically J-band, came up, and when we called them, they jumped on it. They said, we would love to try this out and see if this can work. Because yeah, to John's point, I do think that some of those more joint adhesives certainly could have worked as well. I'm not saying that this is the only way, but it is going to be kind of neat to see, at least from a, from a practitioner or a research or agency perspective, where we don't really, we just want to see good products and good pavements. It'd be nice to see if there's if there's another tool out there to help. And these are kind of unique situations, but sometimes unique situations, they're pretty high risk. And so it'd be, if you're in a situation where you do have a vertical face like that, we'll be really interested to see if this works.
Yeah. Yeah. And I'm excited, like John Young, our good friend in Hawaii, that gets up at the very wee hours of the morning to watch our webinar every month with us. Like he mentioned, I'm excited to see the results when you guys are able to core that and see where that material has
Yeah.
flown through the pavement. I do like his point. His concern is it may only go to the hot side and not do anything to the
Yeah,
cold side.
absolutely.
Right.
Absolutely. That's what we're going to look at. And I'm looking forward to being able to do that and having some findings on that.
Sure. Sure. Hey, Corey, I want to throw this one to you here. The question is kind of, talking about that target of shooting for 200 PSI on soils that have been stabilized with cement. And I know that's specification by specification difference, but especially with you covering across the country, is that a real common target that you see, or do you see?
It's not a
What do you
common
see?
it's not a common target right now, but basically we've seen the benefits of it. Dave Jones, I believe, out in UC Berkeley, has done a lot of studies on it, a lot of micro cracking testing, and basically there's a sound principle behind it. If you get a 600 psi base mat, essentially what you're going to do is create a block cracking every 15-20 feet. The block cracking is then going to reflect up through the asphalt, so staying in a nice low number kind of prevents that and makes a flexible mat.
Yeah. Yeah, and I agree. And that crosses over from soil stabilization into using like an FDR or in any of those type that use that particular bonding agent as well. I know we heard a lot from Brian Diefendorfer and from Ben Bowers in using those kinds of mixes and making sure that we're not getting that material too stiff because of that block cracking issue. And from being a practitioner that dealt with a tremendous amount of reflective cracking in the agency where I worked, and why would we want to create something that generated that block crack, that reflective cracking from the beginning? So
Yeah,
your other point there?
I was just going to say the problem is most contractors assume that more is better. So if I've got a problem, like I said, with the soft spot there in one of the slides, they're going to immediately put more in, and then most agencies are paying out based on how much they're using. So there's no real incentive to use the right amount. This is the minimum amount, and a lot of them we use double or at least a time and a half more than they need.
Yeah.
Yeah, I've heard of that as well. Some agencies just sort of, it may be well intentioned, but there is so much there's a thing as too much of a good thing.
Yes.
Okay, so that the slurry that you showed some pictures of there, Corey, was that a cement slurry or does that help with silica exposure?
Yes, it's helping with silica. It helps with air pollution primarily, but some of the areas are going to that just because there's not a lot of good dustless applications for cement, and cement is so readily available and easy to use that slurry is one option. Slurry is a difficult option just because it has to be pretty much constantly agitated like you would concrete. The only exception to it I've seen is I believe it's Martin Marietta's got a product out in Texas they call Super Slurry that acts a little bit like an emulsion in that there's a chemical that encapsulates the cement particles and they can store slurries. I think they say up to 3 days.
Okay. Great. So do you have a preference between spreading powder or spreading slurry?
Slurry is messy, but cement spread wrong is equally messy. I mean, if I was in a residential area, I would probably say slurry, just because a lot of contractors end up buying a lot of car washes and house washes over cement powder floating off into the woods.
Yeah. Makes sense. That makes sense. That makes sense. So I think there were some really fun things that we got to talk about here today in some of the lessons that were learned out there. I do want to plug that Nathan has got a fantastic review of the construction. Kind of done a little bit tongue in cheek, but a lot of fun, very informative. If you can find that, it is on YouTube, but you can also find it on your social media channels. We always like to let you know that if you'll go to our website, which is ncat.us, that you can find our research there. We have all sorts of, we have documents clear back from the first cycle of the tracker, all posted there together. Pretty good search engine on there as well that can put you towards a specific topic. I always like to invite people to check out the Training in Your Pocket channel, which is on YouTube. They're short, pretty easy to watch videos, especially for folks who are needing to get really high level knowledge of a whole bunch of different tests in the laboratory, some products that are out in the field, some equipment that's out in the field. There's some good videos on there. So please check those out, subscribe if you will. We also have a tremendous amount of training opportunities that we can do, and customized trainings that we like to bring all around the country and beyond. We can come in for a day, for a 4-hour session, for a week-long session. There's lots of topics we can cover. We cover a lot with balanced mix design. Sometimes we just do best practices, especially for a newer and emerging workforce where we've lost so much at DOTs, and even contractors have lost a tremendous amount. We can do some really fun training sessions there. Then also want to invite you on to our next webinar. We're going to go ahead and skip December because it gets so busy and so close to Christmas. We're going to skip that one and go on to January 16th is when our next webinar is going to be. I'm going to flip that over here pretty quick in the next few minutes, that QR code, so that it goes to the new link. And so when you see that come back out around, or if you've got a copy of it otherwise, within about 15 minutes, that'll be switched over. So I want to thank our guests. Corey, thank you very much for your time here. It was really valuable to hear some of your insight and the stuff that you've done across the country. Jason, thanks for your insight as well. After, what is this, your 6th build or so?
Oh yeah, let's do the math. It's adding up there. Yeah, that's right.
Six of the 9 that Jason's been involved with. So he's seen a lot of stuff out there as well. So given that, Nathan, any last words?
Y'all stay tuned for future webinars. We just kind of hit on tools and techniques on this one, but I'm really excited to start talking about really more of the technical aspects of what we were looking at and what some of the agencies are dealing with, and the cool additives that we were looking at. And so yeah, y'all stay tuned. I'm looking forward to seeing you guys every month.
Okay, sounds good.
Thanks, everybody.
See y'all next time. Thanks.